Yes, so I guess we can start now. So, on today we're going to see model serving and deployment. It is going to be a very short slide. So, what do we mean by model serving and what do we mean by deployment? So the first one is model serving. When we say model serving, so we're familiar with building models, right? So it refers to making a trained machine learning models available to application or users. So it can be processed real time or batch data and provide predictions. So the point is now we have built a model, we've trained a model, let's say that. So we've just maybe we have we've tuned it and we've done other things. Okay, so the point is now we have the model and we're using it for our purpose. We can just give it a new data and see the performance of the data and evaluate it. But what about in real time use? Okay, for real time use case, or what about we're trying to use this model, or we're trying to show this model for another people while giving it new data in real time. So the model serving. So the point is, or the answer is serving. Usually, serving is not just for a model, but if there's any type of work that we're doing on the background, and if we finish the work, even if it can be, converter, it can be app, it can be anything, detector, something, some detector, whatever we're doing. After we've done the job, it's like we need to do the serving part. So what do we mean by that serving? So in this case, we made a model because we're working with machine learning models. So input output handling, which is accepting input data, it is a JSON request and returning prediction in a consumable format. So again, it's specifically in this case, we're doing predictions, right? So what do we need to provide is we're going to accept a request that is equation, or so the person will have data. So on our model prediction, we have the training, the test data, right? So a person or the user or anyone who is using the served model will have a JSON structure that is somehow familiar or similar with the test data that we've used for testing our model. And then when they put that data, we will return them the prediction, which is the expected value, or specifically what we have trained the model. We've trained the model based on that test and train. So that kind of format, we're going to respond that kind of format. So we have input output handling. We receive inputs and we return outputs. The other is API endpoints, so serving model via REST or gRPC endpoints, often using frameworks like Fast API, Flask, or Django. So in order to serve the endpoints, uh, we use frameworks like REST or gRPC. So often we use like frameworks, like especially for with Python, we use frameworks like Fast API or Flask or Django. So in this case, we can see Fast API. And then the other is scalability, which is ensuring the service can handle multiple requests concurrently. So we can test the scalability of the model and other things using by model serving, by serving the models. And then latency, minimizing response time for real-time prediction. Uh, so these are the key aspects of the model serving. Okay, sending like requests, or how much requests that our model or our server or our backend can accept per second or per something. Okay, that is the point of the latency and scalability. The other point is deployment. So after serving our model, so we're able to accept input and outputs and things like that, right? So on the deployment part, cloud platforms with free tiers, we might get cloud platforms with free tiers, or we also can use Amazon and other type of spaces or platforms in order to host our work. So deploy models using Radio or Streamlit or Hugging Face spaces, free computer for smaller workloads and with limits based or resource used. Deploying a Radio app for prediction, that you can just check this kind of apps from Hugging Face. Also, Render, like I'm not sure if Render is free now, but it used to host the free hosting for APIs, Fast API and H Plus and other static sites. And it supports Docker for containerized deployment, but specifically focusing on Docker. For this case, we're using Docker in order to containerize everything. So containerization means like Now we have the, while creating our model or while working on that, uh, we have a data, so we have the model features trained, we have the training script, the requirements, and other type of things, which is what we have worked on, right? And like we have an environment, right? What we usually know, we know virtual environments, Python virtual environments, right? So um, the concept of Python virtual environment is it will contain any type of package that are related with the work that we're doing or that are useful for the work. We can containerize them in our environment, right? The package. So it will help us to stop package conflicts and other things. The same goes for Docker. Docker will just contain every project. So it will build an image for a specific project and you can just you can just work on create another image and work on another project for this will make the deployment process simple. So uh, in order to use Docker in our case, so we need to install Docker and then since I will you most of you guys might be using Windows, so we need to, if it is Windows, it is more suited, Docker is more suitable for Linux or Ubuntu. So if it is Windows, you need to have WSL and you need, the backend of the Docker should be connected in WSL. And then we will check if the Docker is running successfully and then we can build our models and our works and host it in specific port, okay? So let's see what we mean by that. First, you need to install Docker for specifically window. You can get the I will send the link here. Also, I will attach the link in our slide. So yeah, here I have shared the link. So specifically, you will install or you will download Docker for the specific operating system that you have for Windows or for in. And then after installing it, you need to open you need to unpack the file and the .exe file. Okay, so I guess I need to share another screen. So here I have opened my PowerShell as administrator. So let's say you guys have downloaded Docker and things, okay? So you can just, sorry, just if Docker is installed in your PC and if it is extracted successfully, you can just see this by writing the command Docker. So subsection runtime for containers. So every details about Docker is there. Also, you can get the version of Docker that you've installed. So the version, the API version and other versions are also here. And then you can also see if you can run simply hello world, okay? So like it will, you can just, so yeah, it will just pull from the existing library or from the previous library that you will create it. Mhm. In this case, so after creating or installing, extracting the Docker, there will be this kind of app. Okay, again, I need to share you maybe the whole screen. Here you can just see if Docker is installed or if it is not. So it is not opening in my case. Maybe you can just extract it from you. Uh, it was it just opened first, and I guess it is a resource issue. She's saying you need to have WSL. I tried to. Okay, there's a comment. I tried the Docker before and can't install to my Windows. You know, Kiash, you're saying you need to have WSL as backing. Yeah, you need to have WS if it is on Windows 10 and 11. So here you can just check if you have installed WSL correctly or not. WSL 2. So also you can install by just WSL 2 install. I think it is better to use Ubuntu. Of course, if you have Ubuntu, then you can go with that. You can go with that time. It's really better. Yeah. WSL will just help us to run the terminals in Ubuntu mode. So still we're now working on Windows. So let me just try to extract it from you because it is not opening. I guess it's because of an resource issue. So you will have a pop-out or you will have specifically a Docker desktop. So you can just check from there. By default, you would choose your backend to run with WA6. So you can also make uh, you can check whether it is running on WSL or not by yourself. Existing installation is up to date. Yeah. So maybe we can just keep this part and we will just wait for itself to install Docker and to extract it. But we can just go to, since it is installed in another part, we can just go to the demonstration. Yeah, okay. So here we can just see the simple example of just training on Iris data. We have, this is mostly the structure, like the structure we're going to implement while implementing a specific project or specifically while serving them in Fast API. So we have the main.py. Here we have a little bit of functions, so it is not that too much. So we can just handle everything here inside the main .py, but otherwise, inside the main.py, the point is we're going to put the endpoints that are going to be called. Like now we have the read route and the predict endpoints, which are going to be called this one as data and this one as post. So if we had a complicated functions inside here, so as usual, we would have classified it under the source or under other modular classifications. But now this is simple. So what we've done is like the predict is the function that is going to be that is going to do the prediction. Okay, so the other part is you guys are already familiar with this. We read the CSV file and things like that. We have just renamed the column of the file, like sepal link, sepal widths. Since we're doing with the iris data, so we know the column. So the sepal links, the sepal widths, the petal links, and the petal widths. So we're trying to predict what type of uh, the species of the plant. Okay, so what specific thing that we need while building an endpoint is this pydantic root, which is now we have in iris request we have a class called iris request, and we have just put this all information here. So this will say that this is the information that I need in order to predict the final result. Okay, so we're going to use this specific class inside our endpoint. So the request of this endpoint is this iris request. Okay. So after that, we can just call the model. Now we're importing the data here, and then calling the model. We're using the simple logistic regression model for prediction. The logistic regression with 200 maximum iteration, and we've fitted the model here. Okay. We're just calling the prediction here and then the prediction probability. So as a return of this function, we're expecting the predicted species, like what is the species of this this input, and then the probability. Okay, what is the probability of this prediction, or what the probability of this prediction being true? That is what we need as a return from the function. So you guys have different data and different, probably you're going to use different type of models with different complications. This is flexible for, this is flexible, of course, in different type of scenario. So the difference is now we can, the first thing to do is here also we can just check if we have Docker in our terminal or in our new terminal inside the PowerShell terminal again here. So you need to build the image for your specific task. I'm sorry. So if you have seen here, there's the app, there's the data, and also there's the Docker file. Inside the Docker file, we we need to include, so like while building an image using Docker, it is going to install, or it is going to read the files inside here. Okay, so we need to copy every data, like copying the requirement.txt, which are simply the fast API, the UV current scikit, and Panda, so, or the useful information that we are going to use, or the, I mean, libraries. Okay, in the others inside main.py, I'm sorry, inside Docker file, we have copied that requirement text, and we need to install the requirement text, right? And then there's the copying the app, which is this is the main.py that we're going to use, and the other is the data, right? So we need to put every dimension or every input, every place or every information that we're going to use. And then we're going to host the file here, right? So Ubicorn, its main app, and the host and the port number is going to be read. So the point is, every information that we're going to host needs to be included on the Docker file. So while running the image, the Docker will read this specific file, so it will build based on this. Okay. So now we're giving it our name, which is iris classifier, and we're building the image. So I've built the image before, so it is not going to be that late. For you, it might take a moment. Okay. So now it's happening. We're done by on building the image. So here is the number or the port number that we've given for the Docker file here, which is 18. So we'll run the Docker file on port 18. So this will give us. So now yeah. Now we're running it on this specific link, so we can access it by going to this specific link. Let's open it here, and we need to wait for a moment. So exactly now we're hosting, or we're serving the file or all the works that we have done with the specific link. So let's go to it. Mm. Or we can just rerun it. Let's just rerun it. Let's reload the page and we will rerun it. First building the image and then running the ports. Wait, here it's already maybe connected. Let's see if this endpoint is triggering this button. So
Could you copy the address? It says UV code running on HTTPS. So just copy and paste it on a browser.
yeah, like I'm just following the link, which is basically similar process. So just clicking the opening this link is specifically it will just track the link. We can also hit that.
Maybe if it's
Yeah, I
already
get
open,
you.
you can check the browser.
Mm-hmm. It's
Will you
already open here, but yeah, you're right. I have already run the file here, but it needs to open it again. It doesn't matter. This is not a problem because if this specific link or if this specific URL was working for this backing, so it could have while executing the functions or the command, it should have altered this terminal, but now there's no change here. So uh, this is not that. We can just open it again. Mm, mhm. Or we can just change the ports here. And let's try building it again. We need to change the number here also if we're changing the port. So
is it going to open on browser?
mhm,
Is it going to open on browser?
exactly. So this is the existing. This is the same function or the cell. You can see that here we have the root and the predicting points, which is what we have stated here inside the main.py. Look here, we have two endpoints, right? Just the root and the predict, which is the main endpoint that will make the prediction by accepting the input request that we have stated like this, right? So we will just open it in localhost since it's we're hosting it locally. So yeah,
Can you show us the
Okay.
browser side by just pasting the URL?
this is the browser. Oh my god. Oh, I thought
No,
like I've
just
shared one of
direct
these things like this.
browser.
Yeah, I thought I've shared the whole screen. That's right. Sorry.
No, we just see the
Yeah,
visual.
I get. Thank you for letting me. Or actually, let me just share the whole screen and we can see, um, we can compare them. So yeah, here is the browser site. So these are the default two endpoints that we have talked about, which we can get here, the root and the predict endpoints, and we can find them here. And the other is inside this one, we can see uh, like what the input request. This is the input request that we have stated in our base code. So this is the requirements in order to make the prediction. We need this input fields to be filled. So changing this number or putting whatever value that we need to predict. So we can just execute the function. So that is what I was saying. So before that, you can just click. Now we can. We're just clicking here. You will just find a try it out button, so you can just try in order to try. So the result or the return will be like this, which is the predicted species and the prediction probability, because that is what we've stated here inside our predict endpoint, the predicted species and the prediction probability. That is what we're expecting. So this will be the returned result that we will expect from the specific endpoint. Right? So this is the browser side. Before that, let me try just something. Mm, give me a second. So yeah, it is not reading the packet at this specific point.
You did not sharing.
Yeah. Okay. This is the page, right? So I'm just not sure why it's not open. So let me try. Let's try another thing. Just maybe running the backend. That's okay. It is not something. We could have just run also this Python the specific main.py file, but we need to say this type of endpoint. So using UV call, you need to cite this type of UV. Yeah, this kind of setups inside main.py, but we could have just run the main.py script. Now we're trying to read them, or we're trying to go through all the file using Docker, not just serving the specific scripts. There's the difference. But yeah, the browser side, the point is, you can see from here, it's just localhost. Then the other part that you need to add is the docs. The localhost/docs will just find this endpoint. And then the default, the predict post, and the other things have just came after going through specific endpoints. When we come to this one, it would just change to read root, and the predict will just change to the predict endpoint. Okay. So this is not assigned by you, but you need to do the /docs. After localhost, you need to do the /docs file. I guess you get the point, right? But also, I was like thinking to show you like directly. We could have. We need to see the like while running this. Response failed to set up container since yeah, we need to build the file again. That is one. We could have so the results or the link. We could have accessed the link directly from here. That is what I'm trying to do. Failed port is already allocated. Run the current. Okay, it is because of the port now. I mean, so we could have just expected here, yeah, your something is running in this port and I'm the mail message from here, and we could have just opened it from there. That is also not here for now. I'm thinking maybe it is from the Docker side, uh, but it is not an issue from the Docker is running properly, the scripts is running properly. We could have just the link is not
ውጡ
working.
አሁን እየተማርኩ ነው ቶሎ በል ውጡ ውጪ ተጫወት
This is really
ቆልጥጣለሁ
not, yeah, but overall, you guys, I guess you get the point, right? Is there any question? It's Ramadan, so yeah. So you need to add expose in your Docker file to expose the port. Mike, yeah, I guess Docker is started because we're building an image. The expose in your Docker file to expose the port. Yeah, we should like we've put it the port, and also we're running fast API, so we're using UV core. So we've also set it up. So you could have also done this inside them. I guess your point is we could have just done this inside our main.py, and we could have run specifically the main.py. But the point is, since we're trying to dockerize or to containerize everything, so we are including every files and every requirements inside the Docker, and just running the Docker to build or to expose our endpoints. So maybe one, I guess, if you get the point, I can try one too.
I have
Yeah, okay. Meanwhile, I will be trying something. Who have question? I'm the Mikhail, I guess you can go.
okay. The model that we used in each endpoints, it's already we get fit from Iris, right?
The model we've run in each endpoint.
Yeah. Is it our friend model or it came from already ready-made model? My question, uh, what I think is
So now we're yeah, yeah. I guess I get your point. Like I guess it's
yeah,
based on your challenge. Yeah, you're not going to use this kind of structure because you have a lot of
yeah,
data. It is not lightweighted, so you need to. I will expect you to train your model locally and to taste it. And at the end of the day, when you decide to serve the model, then you can just serve the model. But here, what we've done is we've just a lightweight. We're just making the prediction since the iris data is just very simple, like very lightweight data we have. So we've just used the logistic regression to train the models. It's a ready-made model. So in your case, you need to train it and you need to replace it with your own type of models. And your endpoint at the end of the day will be the endpoint that will use your new model that is trained and that can accept the request and it request.
can you show us one more time? the code you are showing that to us.
Okay. I'm just once trying to run the Docker again. That is why.
You're not sharing because I will not see it.
I am not.
You are not sharing the screen.
Yes, yes. I get it. Okay. I'm sharing this.
So, what was the question came to my mind is since we are to build a model by training and validating something, finally that model will be served using some kind of endpoint. So, model in what kind of format is going to save our model and then we use it inside the main. For example, can you open
Sorry, I'm sorry. Yeah, yeah.
can you open the main okay?
Can you what? Okay.
Uh, in Windows Care, the main module.
Yeah.
Shall we see? Uh, where do we get the actual model for one of endpoint?
Where do we get one model? So here we're just coding the model here. The model is stated to use logistic regression model here. But what we're using
Okay, so
directly the logistic regression model. But what I'm trying to indicate is you can go. And then Mikhail, if you're speaking, I'm not hearing your voice.
yeah, I just processing things because what I think is we are going to build a model and like this one of endpoint, we are going to use that model. So in what format we save our model and call it or
Yeah, I
use it
get you.
in endpoint.
It's in a pickle format. So while training and saving your model, you just save the model here in model.pickle format, PKL format. So it would be easy. It is easily readable. Uh, so you can just there are forms or there are structures that you can follow in order to read or in order to load your models from, and you can just use that type of structure. So I get your point now. Now we're just directly using the logistic regression model, which is not retrained or trained by our data and things like that, right? So in your case, you're going to save after training the model. You're going to prepare a model folder, or specifically, you're going to put a path for where to save the model for. So it is not a hard work. It will just save your model in a model with pickle format, and you can read the model from there. Also, maybe in stand up, we can see that specific part if you want. Yeah, Samrit, also, can you show us how to use the saved model for prediction? Okay, for this case, I've just imagined how to I was not focused on that specific part. I was just uh, seeing how to serve the model after training it and after saving it, just how to save the model serve the model, because I thought you guys had passed through saving the models and yeah, saving the models locally before this start. That was my imagination. So you can just see to understand that later. It's okay. Also, it is not just a hard saving the model is not just a hard. It's not a hard step. So I'm writing them the Mikhail. Do you get my answer? And do I get your question right?
Yes. One more thing, can you scroll up on this file?
Okay.
Okay, so okay, that's what I want to see. So we imported the logistic regression and then
Exactly.
yes, okay.
Yes.
So for our case, we are going to save our models and import it here, right?
Like, in your case, actually, you're going to import logistic regression or other type of model because those are your base models or your initial models that you're going to train, right? So on the top of those models, you're going to build another type of your model or the train type of form of your model. So it's not like that. It's not like from stuff ምናምን ሳይሆን you're just going to them. For example, like Iris says with this data, we've imported, we read this data like this, right? So there is a format that will help you to read a model just like we can read a data. We're just going to read them like this from a specific path. It is
Okay.
just the same as the data. Yeah.
Okay. In addition to that, since we are already exposed for PVC and MLOps, so the model can be served as a software in addition another place and call it from here,
In other place like what?
like as a server, any server. It was hosted there, and we can call
Yes.
it from here.
Yes, that is the deployment state. So if you get a free version of anything that can deploy your model, then of course. So what is going to happen is specifically, okay, again, let me share. So now if you're seeing this page, or we can just paste this one. If we, now we can get it from localhost, okay? Localhost/docs, or just let's say the localhost. We'll just say welcome to this Iris classifier API, which is stated in our code, and inside the docs, you can see this one. This will be popped out. So the point is now we're running this in localhost, which is locally. But if you are deploying or if you're deploying it, so this specific link, which is not localhost, but another domain name, will be able to be accessed by another people with their own PC. That is the point. Now we're accessing it with their localhost. So yeah, people can access your model. So again, now we try it out. So now it is working. That is right. Try it out. You can change your inputs, like whatever type of input that you have on point one. Here we can put it to 0.2, let's say. So executing, now we have nothing. So this is the type of structure that we're expecting from the answer, and executing it will respond. This is species is Iris Setosa, and the prediction probability is 0.97, which is basically we will expect it to be true. Yeah.
ምናልባት የቋንቋ እጥረት ሆኖ ሀሳቢ በደንብ ሳልገልጽልሽ ቀርቼ ሊሆን ይችላል።
It's fine.
ሞዴላችን አለ። ሞዴላችንን ዲፍረንት ካይንድ ኦፍ ኤፒአይስ ባይ ዲፍረንት ዩዘርስ መጠቀም ቢፈልጉ እና የእኛን ሞዴል ሰፓሬትሊ ሰምዌር የሆነ ሰርቨር ላይ እንትን ብለን ነው ማለት ዲፕሎይ አድርገን ነው የተለያዩ ዩዘሮች አዘ ሰርቪስ ሊጠቀሙት የሚችሉበት አይነት አርኪቴክቸር አለ እዚህ ላይ ወይስ እንደዛ መጠቀም እንችላለን? ኢንስቴድ ኦፍ ኢምቤድ አድርጋ ነው አንድ የዚህኛው ልክ አሁን እንዳሳየሽን ኤፒአይ ውስጥ ከዛ የሆነ ቦታ እንትን ብለን ጀስት ስሩ ዛት ኤፒአይ ነው አክሰስ እያደረግን ያለ ነው። ግን ሞዴሉን የሆነ ቦታ አድርገን ነው የተለያዩ ኤፒአይዎች ደግሞ እሱን ዩዝ ማድረግ የሚችሉበት አይነት አርኪቴክቸር አለ።
ሶ ገባኝ። የፖይንት ባኪንዳችንን ሳይሆን ውስጥ የምናደርገው ሌላ ሰው አክሰስ እንዲያደርግ የምንፈልገው ሞዴሉን ስፔሲፊክሊ ሆነ ሞዴሉን ብቻውን ሰርቭ ማድረግ ማለት ነው። ሶ አሁን ላይክ ኤምኤል ፍሎ ምናምን ስትጠቀም ኤምኤል ፍሎ ኢትስ ኤ ፍሬምወርክ አይደል? ጥያቄ ገብቶኛል። አሁን አንተም አብን ኦን ዘ ሴም
ለምን ለምሳሌ አሁን ክሬዲት ስኮሪንግ ደግሞ ብዙ ባንኮች መጠቀም የሚፈልጉ ብለን እናስብና ወንስ ሞዴሉን ቦታ ውስጥ አድርገን ነው እነዛ ባንኮች ደግሞ ለራሳቸው ኢንታይ እንዲጠቀሙ እናስብ ማለት ነው።
Yeah, I get your point. So እንትን አለን አሁን ML flow የሚባል it's possible. So ML flow የሚባል framework አለን and there could also be other frameworks. አሁን ML flow እንደሚያደርግልህ you can just track እና እነዚህ ሞዴሎችን ብቻ አንተ wherever you train the model, wherever part like እንዴትም ሰርቭ አድርጋቸው ምናምን you can just save እና you can just put your model or that pickle file እዛ ከዛ anyone accessing that ML flow ወይም that framework can access your and access that specific model that is built by you ለዛ እሱ አርኪቴክቸር አለ ML flow I guess later ምናምን like next week or some of the weeks ላይ እናያለን so ምን አይነት work ነው so it's kind of DevOps አሁን ለኖርማል ለሶፍትዌር ኢንጂኒሪንግ DevOps እንደምንለው it's for machine learning ደግሞ MLOps አለ machine learning operations so it will help you to serve or to give your machine learning model specific so there are tools እንደ ML flow አይነት ቱሎች አሉ also I believe there might be also an option specifically a model can እዚህኛ deploy እንደምናደርገው ሙሉ ባኪንጉ maybe to yeah deploying በሞዴል ብቻውን እንትን አይሆንም ያን ያክል valuable አይሆንም because people need to know how to run እና ምን አይነት expectation እንዳለው ምናምን but ML flow would be a good option so yeah, there's that kind of option እና ML flow እናያለን ከዛም ውጭ ግን ሌሎች አይነት አማራጮች ይኖራሉ እንደሚካኤል ድርጊት ማለት ነው
Thank you so much.
Any other question? If there is no other question, I guess ሌላ ጥያቄ ያለው ወይ ያልገባው ሰው አለ አሁን we're able to run so ያየነው ሀሳብ ዶከር ኢንስቶል ማድረግ አለብን ከዛ like የፈለግነውን ስራ ሰርተን so we need to በAPI ሞድ ሰርቭ እንዲደረጉ ማድረግ አለብን ዶከር ፋይላችንን አድጀስት ማድረግ አለብን then image build አድርገን we can just run the docker file ጥያቄ ያለ ሰው አለ Nuriye, can you share us your idea? Muhani? Okay, in that case, thank you everyone for being here. I will just stop the recording and now we can meet for next time. መስፍን
እሺ ፋይሉን ሼር ታደርጊናለሽ?
አዎ
እሺ ቴንክ ዩ